Last episode, you watched batch norm pull a layer's activations back to mean 0, variance 1, and you saw it tie straight to the toynet's hidden values 0.4621 and 0.2449 made standard. That was the final knob. 18 episodes, 18 knobs, the gradient, the step size, momentum, atom, the schedule, clipping, normalization. Tonight we stop turning knobs one at a time and turn them all together. On one real run, start to finish. No new tricks, just the whole machine, breathing. Here's the misconception we have to kill first, because it's the most common one of all. People think a good training run is a single number going down. Lost drops, you win, done. But a real run has two numbers, and the gap between them is the entire story. Train loss is how well you fit the data you've seen. Validation loss is how well you do on data you haven't. One falling while the other rises isn't success. It's the most famous failure in machine learning wearing a disguise. Just pick the biggest model and the most epochs. No, more epochs past a point doesn't make you smarter. It makes you a better memorizer of this exact training set. Watch our run. For the first 12 epochs, train and vol fall together, locked, learning real structure. Then they separate. The model keeps lowering train loss by memorizing noise that doesn't generalize. That separation point, epoch 12 here, is where learning quietly becomes memorizing. The learning rate is just speed, bigger is faster. We buried this one early, but here it earns its place in the config card. Our run uses 3E4, the Adam default we called the good default. Not because it's fast, because it's the value where the loss curve is smooth instead of jagged. Crank it to 1.0 and you get the magenta divergence you saw in episode 5. The right learning rate isn't the fastest one. It's the one that lets every other knob do its job. Cosine, warm-up schedules, that's just fiddly decoration. It isn't. The schedule is when you trust your steps. Early on the net is random. You warm up 500 steps of ramping in, so a big step doesn't wreck a fragile start. Then cosine decay eases the step down toward the end, so you settle into the minimum instead of bouncing around its rim. Same learning rate number, very different ride because of when it applies. Normalization and clipping are safety nets you only need when something breaks. Wrong framing, they're what keeps it from breaking on every step invisibly. Batch norm holds activations in range, so gradients neither vanish to 3.2E7 nor explode to 1.0E3. The two failures you watched in the deep net bars. Clipping at norm 1.0 catches the rare spike before it lands. You don't see them work, that's the point. A good safety net is one that never gets used loudly. So here's how to actually read a finished run. The skill this whole series was for. Final train loss 0.0420. Nice, but alone it's meaningless. Final val loss 0.1810. Accuracy 0.94, that's the honest score. And the gap between train and val, that tells you exactly how much you overfit and whether to add regularization next time. 3 numbers read together, not one number going down. So let's build the whole run as one file, nntrain realnet.py. Everything from this series shows up exactly once. The model, the Adam optimizer with our Canon betas, the cosine schedule with warm-up, gradient clipping, and the train plus validate loop that produces the two curves. 40 lines. Every line is a knob you already understand. Up top, the config, and this is the card you'll see in the corner of the figure. Learning rate 3E4, betas 0.9 and 0.99, epsilon 1E8, the Adam moments from episode 8, 20 epochs, warm up 500 steps, then cosine decay. Clip norm 1.0, reading this block out loud is reading the entire series back to yourself. The model, a 3-layer MLP with batch norm between the linear layers. The exact normalization you just learned, placed where it belongs, before the non-linearity. This is the headline classifier the whole course quoted slices of. Now you see it whole. The optimizer and scheduler, 2 lines, Adam wires in the betas and epsilon. The scheduler is a lambda LR that ramps linearly for the first 500 steps, then follows a cosine down to near zero. Notice they're separate objects. The optimizer decides direction and per parameter scale. The schedule decides the global step size over time. 2 different jobs, episode 8 and episode 6, cooperating. The training step, the heart of it, forward, compute loss, backward. That's the backprop graph from episode 3 doing its work. Then clip grad norm at 1 more before the step, so a spike never reaches the weights. Then optimizer, step, then scheduler, step, order matters, clip before step, step before schedule. Get that order wrong and the safety net fires after the damage. And the validation pass, torch, no grad, model in eval mode, so batch norm uses its running statistics instead of the batches. This is the line that produces the second curve. Most beginners skip it and stare at train loss alone, which is exactly how they ship an overfit model and never know. The val loop is cheap and it's the only honest mirror you have. The loop runs 20 epochs, recording train loss, val loss and accuracy each time. At epoch 0, both losses sit at 23026. That's ln10, the loss of pure guessing across 10 classes, the honest starting line. By epoch 20, train is down to 0.8, val to 0.31, accuracy 0.94. And right around epoch 12, you'll see the 2 curves part company. That's it, that's the series. 18 knobs, 1 run, and now you can read a training curve the way a senior engineer reads it. Not did the number go down, but which number, by how much, and what's the gap telling me. Every figure you've seen reconciles to this one. The gradient that started at 1.65, the bowl with condition number 10, the 94%, all of it was always pointing here. Go train something, you know what every knob does now. Thanks for watching.